Lesson 6.3 on inscribed angles. Now, inscribed angles, I hope you recall, are angles whose vertices are actually located on the circle and whose sides are chords of the circle. Like, for example, we have angle CAB there, which is an inscribed angle. Inscribed angles have some specific properties that we're going to be studying in today's lesson. First, the measure of an angle inscribed in a circle is exactly half the measure of its intercepted arc. For example, in this diagram here, if the intercepted arc, arc BC, has a measurement of, say, 82 degrees, then we can conclude that the measurement of angle BAC is half that, or 41 degrees. Second property of inscribed angles is that if two inscribed angles intercept the same arc, then those angles are congruent. So, for example, here, this inscribed angle CDB also intercepts arc CB, just as angle BAC does. So, again, if angle BAC is 41 degrees, as we established in the last property, then, since angle BDC also intercepts the same arc, angle BDC also has to measure 41 degrees. In addition, inscribed angles have a few more properties to discuss. Property 3, an inscribed angle that intercepts a semicircle is a right angle. So here we have ourselves a circle where we have a diameter BC forming a semicircle, arc BDC. That semicircle has an inscribed angle that intercepts it, angle BAC. So, since arc BDC equals 180 degrees, then the measurement of angle BAC has to equal 90 degrees. Property 4. Parallel lines intercept congruent arcs on a circle. So for example, if we draw a line segment DE, which is parallel to segment BC, and we state that arc BD has a measure of 50 degrees, we can then conclude that the arc opposite arc BD, in this case arc CE, is also 50 degrees. And finally, one further property of inscribed angles, the opposite angles of a cyclic quadrilateral are supplementary. Now, cyclic quadrilateral is not something that we've discussed before. We know what a quadrilateral is, a polygon with four sides, but a cyclic quadrilateral is a special quadrilateral where all four vertices of that polygon are on the sides of the circle. So for example here, quadrilateral ABCD is a cyclic quadrilateral because all four vertices, A, B, C, and D, are on the circle. So in a cyclic quadrilateral, the opposite angles are supplementary. For example, if angle BAD is 100 degrees, then we can conclude that the angle opposite that in the cyclic quadrilateral, in this case angle BCD, is going to be 80 degrees because the two of those angles together add up to 180. Likewise, we can also state that if angle CDA is 65 degrees, then we can conclude that the angle opposite that, or angle CBA, is 115 degrees. This concludes today's lesson.